Hi, this video is meant for a guideline to walk you through how you can write full ion equation and what to expect for excellence level. So for in revision 2 exercise, you are given two chemicals. One is potassium permanganate. So potassium permanganate is KMnO4 added to iron 2 sulfate. So first of all, we need to determine which of these chemical undergoes reduction and oxidation. Now, one way to tell very easily is by looking at the typical function for this chemical, and there are two very strong oxidizing agents used in laboratory. One of them is KMnO4, which is an oxidizing agent. So any oxidizing agent will undergoes reduction. And also, if you are given iron 2 ion, there's only one feasible or possible reaction, which is oxidize to iron 3. So from here, we can actually determine iron 2 undergoes oxidation. Okay, so the species that undergoes oxidation is Fe, okay, 2 plus. And in this case, the color would be green. So if you refer to the result sheet, okay, back to the first few pages, you can see iron 2 is green. So from here, we have iron 2, okay, as green, and the one that undergoes reduction will be permanganate ion, which is MnO4 minus, and the original color is purple, so not so sure, refer to page 2. So you have this permanganate, okay, as purple color ions. So from here, okay, the oxidant, which is synonym to oxidizing agent, is the chemical, KMnO4, and reductant, which is a reducing agent undergoing oxidation, is FeSO4. Okay, so to continue from here, okay, we're going to proceed from Fe2 plus, present in iron 2 sulfate, oxidize to iron 3, and 2 plus or 3 plus is only different by 1 plus, okay, which means it loses 1 electron. So whenever we write electron on the right hand side, means it loses electron. So we have iron 2 ion, which is green in color, so your observation will have to be written in this way. Green iron 2 ion is oxidized. We do know it's oxidation, so oxidized to you can put out yellow or orange or even brown depending on the concentration. So say I'm going to choose orange, Fe3 plus ions. Okay, changes in oxidation number is from +2 to +3, the one before and after. And the transfer of electron means does it lose or gain? So in this case, since it's oxidation, it loses 1. So lose, okay, 1 electron. And justify, you have to explain why you choose iron 2 sulfate undergoing oxidation. So sort of you're going to combine what you have written, okay, in the previous 2 rows to explain and justify the reason why you choose FeSO4, the undergoing oxidation. So in this case, we have iron 2 ion oxidized to Fe3 as it loses electron, 1 electron, by changing its oxidation number from +2 to +3. So this is one half of the answer. Then we move on to permanganate. So in the previous lesson, we went through how permanganate +7 reduced to +2. So do check the previous video how we can derive this half equation. But if you missed that video, I'm going to just summarize what you need to understand before you write down this half equation. So We have purple ions, which is permanganate on the left-hand side. As you run the experiments, you will see that the purple solution becomes colorless. That's how we know it's Mn2+. Since it's reduction, we do know that electron will be gained on the left-hand side. So I'm going to go through that 4 steps in balancing. So if forgotten that 4 steps, just go back to the previous video. That will guide you through how you balance the equation, especially slightly a little bit more complicated like this one. So first, I'm going to balance the element other than H and O. So in this case, Mn is already balanced, 1 each. And then I'm going to balance it all by adding water molecule. So I'm probably going to change the color just to highlight. So H2O is the next step. And since we're going to balance all, and we do find there are 4 oxygen on the left, so I'm going to add 4 on the right. And we have balanced the oxygen. And your very next step is to balance hydrogen. So to balance the hydrogen, you need to count how many hydrogen on the right, which give you 8 hydrogen, and it's H plus, okay? Which is hydrogen ions on the left hand side. And finally, you are going to find how many electrons to be added. So you're going to do some mathematical calculation. So again, I've shown this in the previous video, but if you've forgotten, I'm going to summarize what you need to write down to find your X electron. So manganate is on the left hand side. That give you -1 plus 8 for hydrogen 1. And X electron, say if we're not sure, this is what you're going to put down in the very first step. Okay, then +2 for manganese. And water molecule is 0, so I'm not going to put down 0. So when you solve your max, you will have a -5. I'm going to cancel out electron that give you excess 5. Okay, so I am going to erase this X and add in number 5. Okay, then the observation to be written would be, so we have purple permanganate ion, and we know it's a reduction, so we are going to use the word reduced to colorless manganese ions.